This is section 2.4 notes video, slides 19 through 21. All right, section 2.4, we are learning what we call the chain rule. So this is a very important rule for how we take derivatives of more and more complex functions. So let's read this and then we'll try to understand it. So it says, let y equal f of u and let u equal g of x, where f prime of u and g prime of x both exist. Then the composite function defined by f of g of x, which you could write as f of g of x or f of g of x, has a derivative given by f of g of x equals f prime of g of x times g prime of x. I apologize, there's a typo here. It should say f of g prime of x equals f prime of g of x times g prime of x. All right, so what you want to make sure you understand, okay, is that if I have f of u and I want to find its derivative, that's going to be f prime of u. But if I'm taking the derivative with respect to x of f of u, then we have to realize that u must be a function of x. And so in order to take that derivative, we're going to say f prime of u, but then times whatever the derivative of u is with respect to x, or we might say u prime there. All right, so how do we think about this? All right, so let's say that I have some function. I'm just going to call it, just so we don't get the variables confused, let's call it h. All right, h of x is 3x plus 2 quantity squared. All right, so now for our example, okay, this inner function 3x plus 2 we will call g. All right, so really this is like saying g squared or g of x squared. All right, so how do I find h prime? Well, h prime of x says, all right, so if we look at this rule, it says when we have f of g of x, we're going to take f prime of g of x. So g of x stays the same. All right, so how do I find the derivative of g squared? Well, that would be 2g of x, right? But g of x is 3x plus 2, plus 2. But then the rule says times the derivative of g. So what is the derivative of g? Well, the derivative of 3x plus 2 is 3. So that means that h prime of x is, well, if I have 2 times 3, that's 6, right? So I have 6 times 3, so 18x, and then 6 times 2 plus 12. So if I had 3x plus 2 quantity squared, and we find its derivative, that would simplify to be 18x plus 12. Okay. Now, the reason I've selected this example is because this is an easy one to show we're right by rewriting h of x. All right, how do I rewrite h of x? Well, it's 3x plus 2 quantity squared. So if I multiply that out, I get 9x squared plus, and I would get 6x plus another 6x, that's 12x plus 2 times 2 is 4. So that's the original h of x. So then how do I find h prime of this version? Well, we would bring the 2 in front. 9 times 2 is 18, x to the first, plus the derivative of 12x is 12, plus the derivative of 4 is 0. So notice 18x plus 12, 18x plus 12. So then a lot of times people say, well, why do I even need this thing called the chain rule if I could just do it that way? Well, that is a great question. So let's say that I have some new function, all right? I'm just going to call it f of x, all right? And let's say that that was now not 3x plus 2 squared, but let's say it was like 5x minus 6 to the 5th power. So of course, okay, I could multiply that thing out, but how annoying is it to multiply 5x minus 6 to the 5th power out? Well, it's pretty annoying. So the easier way would be to just use the chain rule. So f prime of x then. What is the chain rule? Chain rule says, okay, if we have f of g of x, so we have 5x minus 6, that's on the inside, that's like g, And the fifth power, that's like f of x. So we're going to take the derivative of a fifth power, which is 5 times whatever to the fourth. So 5x minus 6 on the inside, and then times now the derivative of g. So what's the derivative of 5x minus 6? That's 5. So we found the derivative, which was so much easier than multiplying 5x minus 6 to the fifth out. All right. Now, that's an example of where we could do it a different way, but it's a lot easier to do it with the chain rule. Now, let's take an example like this. Let's say we have some function, I'll call it h of x, and it is the sine of 3x plus 5. All right, so now we can't multiply this out. We can't distribute the sign. We can't do anything. The only thing we could do to find the derivative is to use the chain rule. So what is the derivative? All right, so sine is the function on the outside. 3x plus 5 is the function on the inside. So we take the derivative of the outer function. What's the derivative of sine? It is cosine of, and we leave the inside the same, 3x plus 5. Then we multiply by the derivative of the inside. So what's the derivative of 3x plus 5? It is 3. So the derivative of sine of 3x plus 5 is cosine of 3x plus 5 times 3. All right. So now we can get even more complex functions, all right, which you will see through some of our examples. All right. So let's move on to slide number 20. All right. So slide 20. If I have y equals the sine of x squared plus 1, all right, then what is dy dx or y prime? Well, once again, just like we did a minute ago, what is the derivative of sine? It's the outer function. So the derivative of sine is cosine of x squared plus 1. Remember, you leave the inside function the same. Then you multiply by the derivative of the inside function. So what is the derivative of x squared plus 1? It is 2x. Now, we might rewrite it. I like to always put the constants in front. So 2x times the cosine of x squared plus 1. All right, the next one. All right, y equals the quantity 3x minus 7 to the sixth. All right, so dy dx. All right, so remember, 3x minus 7 is the inside function. The sixth power is the outside function. So derivative of a sixth power, that's going to be 6 times the inside to the fifth. All right, so the inside is 3x minus 7 times the derivative of the inside. So derivative of 3x minus 7 is 3. So now we might rewrite it as 18 times the quantity 3x minus 7 to the fifth. Please do not think about multiplying this thing out, 3x minus 7 to the fifth. That is definitely not going to be the way that you want to do it. All right, the next one is actually an even more complex function because I have cosine to the fifth of x squared minus 3x. Now, what does that really mean? When I put the fifth power there, it actually means that I have the cosine of x squared minus 3x all to the fifth. So that means that this is actually a function inside of a function inside of a function. So there's actually 3 functions here. There's the fifth power, that's the outermost function. Then I have the cosine, the next function. Then I have the x squared minus 3x, the next function. So we're actually going to have to do the chain rule twice. So dy dx. All right, so first thing, derivative of a fifth power is 5 times that thing to the fourth. So inside stays the same, cosine of x squared minus 3x. Okay, then we multiply by the derivative of the inside. So now forget about the fourth power, the fifth power, whatever. Now I have cosine of x squared minus 3x. What is the derivative of cosine of x squared minus 3x? All right, so derivative of cosine is negative sine of, inside stays the same, x squared minus 3x times the derivative of the inside. All right, so derivative of the inside, x squared minus 3x. That would be 2x minus 3. So now we generally like to kind of make this look a little nicer. So I'm going to rewrite. I'm going to bring my 5 in front. Then I've got this 2x minus 3. I also have that negative sign, so I want to bring that in front. Negative 5 times 2x minus 3. Then I'm going to kind of get rid of some of these parentheses. I have cosine to the fourth of x squared minus 3x times sine of x squared minus 3x. All right, so that's the nicest looking way that we can give that answer. All right, so now moving on to slide number 21. Okay, we have a couple more examples, but now these examples are not analytic problems, these are numeric problems. So we've seen this presentation before, but if x is 3, f of x is 4, g of x is 5, f prime of x is 7, g prime of x is 8. But if x is 5, f of x is 5, g of x is 11, f prime of x is 2, and g prime of x is 4. So now it says calculate the derivative of f of g of x at x equals 3. So first of all, let's understand notation. F of g prime of x. What is that going to be? It's going to be f prime of g of x times g prime of x. So now I want the derivative at 3. So I really just want f of g prime of 3. So what does that mean? I want f prime of g of 3 times g prime of 3. All right, so f prime of g of 3, right? That's that inner part there. So what is g of 3? G of 3 is 5. So I have f prime of 5, but then remember, I still have g prime of 3. All right, so what is f prime of 5? So f prime of 5 is 2 times g prime of 3, 8. So this derivative is 16. All right, one more example here. Calculate the derivative of g of f of x at x equals 5. All right, so remember, g of f prime of x is going to be g prime of f of x times f prime of x. All right, so now I want it at x equals 5. So g of f prime of 5 is going to be g prime of f of 5 times f prime of 5. All right, so g prime of f of 5. Well, I have g prime of, what is f of 5? F of 5 is 5. So I have g prime of 5 times f prime of 5. All right, so g prime of 5, look back up at the table. G prime of 5 is 4 times f prime of 5, which is 2. So 4 times 2 is 8. So my answer would be 8. So that is slide number 21.